Of course, we are here talking about the electric vehicle. Just understanding how this works. I know I've been talking to you before we even started recording, and you said, no, to understand how it works, we have to go back to the combustion vehicle.
Yes.
How?
The reason why we have got to start from the combustion vehicle is for us to then understand what has changed, how we have moved or transitioned to electric vehicles.
Okay.
So from the combustion vehicles, which we call the combustion ignition vehicles also, we have got fuel that is burning, and then it turns the engine, whereby we've got the pistons moving up and down the crankshaft. But now with the electric vehicles, we are saying we have moved from that, and we want to use electricity to drive an electric motor, then we get the vehicle into motion. But in between, there's a gap that we have bridged to get to electric vehicles, whereby we've got hybrid vehicles. So for hybrid vehicles, we are saying there's the use of the usual engine, which is either petrol or diesel, and then the electric side, where we've got the electric motor. So the norm is under low speeds, for example, 40 kilometers per hour, in the urban areas, you'll be running on electricity. But for any speed above that, you are now using your fuel, the petrol or diesel. But with an electric vehicle, the one which we have here, we have gone purely electrical. So the concept is the storage of the DC, which is direct current, the electricity that we use to run the vehicle with, it's stored in a lithium battery. So this lithium battery is laid on the floor of the vehicle, below where we sit and put our feet on. It's below that. Then there's a cover which protects the battery. Because the unfortunate part is that the lithium battery that we have on the electric vehicle costs 60% of the total cost of the vehicle. So any damage to the battery means you are more of buying a new car, a new electric car. So we want to protect it in as much as we can. Then secondly, from the lithium battery, we then have what you call an inverter, which is in the front of the car. Our power is stored in DC, which is direct current. So we've got two types of power: electricity, direct current, and alternating current. But for us to then turn the electric motor, we need alternating current. So when you've stored our power in the lithium battery below the car in DC, it's supposed to be converted into alternating current, and it's done now by this unit here, which we have. Is the one that's transferring the power from the lithium battery below to this unit here, and is converted into alternating current. Then it goes down to that silver component below there, which is the electric motor, and it's now able to turn, the alternating current is now able to turn the electric motor, and we get our motion. From the turning of the electric motor, there is direct transfer of the top or the turning power to the wheels, and then we get our car in motion.
But
and
where we still need
the battery. Right. Remember, we have said that our car will be in a stationary position. It's not running. So for us to start and get the car running, this is where we get the power. And also for us to be able to store power for other electrical components like headlights, indicators, wipers, is stored. The power used for that is the usual battery. But for us to be moving the car to replace, for example, the use of petrol, we are now using the DC, which is in the lithium battery. So the two batteries work together, but this is specifically for starting the car and other accessories. Your aircon and everything, we are using this one in order to get those things.
They refer to an electric vehicle as a car that does not have an engine.
Yes.
Maybe just to make us understand, is this true, and what are we saying? That there's no engine.
Okay. Basically, when you say an electric vehicle does not have an engine, what you are trying to say is that we don't have the usual engine, the one which runs on petrol and diesel, has got pistons where we burn fuel and we emit carbon emissions. With this one now, what we have as the inverter and the electric motor, those are the components that run the car. So in other words, we are saying, instead of us having various components, my understanding of the combustion ignition engine is that when you burn the fuel, you are pushing the piston down, it turns the crankshaft, then the crankshaft transfers that torque or the rotating motion to a gearbox, and then the drivetrain to the wheels. So that's where all the power is lost. We lose efficiency through all that. But with an electric vehicle, We have got electricity turning an electric motor, and there's direct transfer of that turning torque, the turning moment, the turning power to the wheels. So that's how we get the efficiency on the electric vehicle. That's why we are saying it doesn't have an engine, but it has an electric motor.
All right, then obviously someone would then say, even if it's got electricity is extremely expensive.
Okay.
Is there an advantage of using electricity? Just get your fuel. It's cheap actually. It's $40 a liter.
Okay. Where we get the efficiency also is on the amount of electricity that we need to use to fully charge the battery. The battery that is on this E6 is a 70 kilowatt, 7.7 kilowatt battery, meaning that the electric motor is 70 kilowatt also, and we just need an hour to charge that battery. And how much energy do we need? It costs us $10 US. But for the range that we get out of the $10, we get 500 kilometers. In other words, we are saying if we recharge the battery, we can travel to Blaawai at $10. But for us to calculate the amount of fuel that we need, estimate, let's say at 10 kilometers per liter, we need 50 liters times $50. Already we're at 75 and above. So in other words, if I'm driving my E6 to Blaawai, I'm using $10 and you're using above 75 or 8. So in other words, I'm saving close to $60 to $70 where you're spending that much.
600 kilometers on this vehicle. What's the range here?
500. 500. With a 7.7 kilowatt battery, you've got 500. So it's here to Blaawai, to Blaawai.
How long does it take to charge?
Okay. It takes about an hour and we're fully charged. So the concept is there's the 80-20 rule. For us to get the battery charged to 80%, it takes us less time to get to 80%. Then the remaining 20 to get the battery fully charged, it then takes longer. So it's all accommodated within the hour. Within an hour, we'll be fully charged and then you travel.
Isn't there a risk of battery running out on you? Does it give you any warnings? What happens? How does the car communicate to you in terms of the power of the battery?
Okay, I'm sure most of the vehicles that we have now, they give us a range. If we check on the dash, there's a range. So if I'm driving and I've used, let's say, a quarter tank, I will know that the remaining fuel will take me for 340 kilometers. We all know that. So it's the same concept with the electric vehicle. When you're fully charged the battery, it gives you the range of 500 kilometers. So when you travel, we are sort of reducing and subtracting from the range. It then communicates the number of kilometers that you can still travel at the same battery capacity. So there's no risk of us running out of power. We actually know how far we can travel to the next charging station. So for the chargers that we have, they're actually categorized into type 1 charger and type 2 charger, and you can also have a type 3 charger. Mm-hmm. But usually what happens when you acquire an electric vehicle, it comes with the correct type of charger. For example, this one is a type 2 charger, and the charging station has got to be compatible with the type 2 charger. So the matching of the charger to the electric vehicle makes it difficult to interchange with any other model unless they've been made universal. But as of now, they are type 1 and type 2 chargers. So this is the type 2 charger.
So you're saying if I have a solar system at home, I can still charge it?
Right. The various types of batteries that we've got a 110 voltage battery, we've got a 230, a 430. So the first one is for the household, and the battery size has got to be less, and then it gives us a lower range. So for these ones, these are industrial sizes, and that's why we've got a higher range. So a phase one charger, the household one will accommodate certain types of batteries, and the charger has got to be customized to be plugged to the household electricity system. But so this one is an industrial one. So this is one of the chargers that we have for our E6, and as you can see already, this is the charger, and when you bring the vehicle, you just plug it out, and then already you are charging. So as you can see, very handy. It's not as big as we might think. It's very reasonably within what we can actually have, be it at home, at the workplace. But this is the charger. It's one of the chargers.
So 500 kilometers is the maximum
yes
distance you can get, no matter how good a driver you are.
Actually, what happens now with an electric vehicle, which is one of the advantages, when you are all traveling anything below 120 kilometers per hour, that does not affect the amount of electricity we are using or drawing from the battery. But if you go above 120, then we then begin to get some slight differences. So what I'm saying is that what you use at 60 and what I use at 120 is the same, which is an advantage over the petrol and diesel cars. The more you go up, the more you consume. But with an electric vehicle, and I'm happy that our maximum speed limits are 120 in Zimbabwe. So in other words, we are saying there is reasonable consumption of power, and we are able to get our 500 in those reasonable speeds, 120 and less.
All right, tell me about the E6. What sort of vehicle is it? We know it does 500 kilometers, or at least 500 kilometers on a single charge. Tell us about the history of the E6 and why you think this is special when it comes to Zimbabwe, because now it's one of your flagship vehicles.
Okay. One of the things that we have observed with these brands is the issue of affordability. The Zimbabwean market, of course, we can afford certain brands, but we are actually limited in terms of how much we can afford and actually revamp the transport industry. So with the E6, it's a Chinese brand, it's coming from China. The charges, the cost of acquisition actually is reasonable compared to other brands. For example, if I say Tesla, not many of us will be able to acquire those models. So this is reasonably affordable when you talk of the electric vehicles. And one good thing is that the BYD brand is evolving over time. We have got the first model that we acquired, the minibus type. It gave us its benefits, but it had a lower range. Whereas this one has given us a higher range, which is 500. So it's evolving and it's affordable, which is why we are going the Chinese route. It's actually enabling us to revamp the fleet and acquire more electric vehicles.
Talk to us. I see that you guys are using it for your shuttle services. What's the advantage of using electric vehicles over the normal combustion vehicles?
Okay. The maintenance cost of an electric vehicle is 3/4 less than maintaining a fossil fuel vehicle. What do I mean? For example, if my cost of maintaining the petrol or diesel engine vehicle is $100, on this one I use $25. So it's 25. It's a quarter of the total maintenance cost of the gasoline or fossil fuel car. The reason being, it now answers that question which you're asking, but people say this does not have an engine. When we don't have the compression ignition engine, we have eliminated a number of components. We have eliminated the maintenance cost. We don't have a gearbox. We don't have the drivetrain. Drivetrain is the prop shaft to the diff, to all those elements. We have eliminated those. We don't have pistons. We don't have the crankshaft. The rockers, gasket ratch, all those things are eliminated. And we remain with the suspension, we have the electric motor, we have the tires. So the cost of maintaining the electric vehicle has got to do with tires, the suspension, and the electric motor. And fortunately, the electric motor runs for a very long time without requiring maintenance. So it's about our tires, our driving behaviors, the condition of the roads, and the suspension. That's why we are now saying it's less costly in terms of maintenance than the ordinary vehicle.
And then lastly, what would you advise the person who's thinking about it? Is this where we are going in the future globally? Are electric vehicles getting into the market to that level whereby very soon the combustion vehicle is going to be an ancient animal?
Okay, let me give the target of USA. Some states in USA have given 2030 as the cutoff year for fossil fuel vehicles. So this is the global trend. Whether we like it or not, as Zimbabwe, the fossil fuel vehicles will be banned because the fight is to protect the environment. By the way, this car does not have an exhaust. Why is it so? It doesn't emit emissions. It doesn't burn fuel and produce smoke, the usual smoke that we see when a car is running. So it's the trend, and you cannot run away from this. It's a global trend. And we want to protect the environment so that we're able to pass it on to the next generation, and they will be able to enjoy also the way we have done. Some of the challenges that we are struggling with, issues of global climatic changes, cyclones, hurricanes, heat waves, all those challenges are to do with the amount of emissions that we are also emitting into the space, and then we are affecting our livelihoods. So this is the way to go. Of course, we are yet to address issues of infrastructure, charging stations, but I'm sure those are closer and more affordable to us than losing the environment, because it affects us in a bigger way. So it's the way to go. Electric vehicles is the way to go, and the drive at national level is that we should be moving towards electric vehicles.